Alright, so we said if we're going to do a hypothesis test, we create our null hypothesis and our alternative hypothesis. That determines whether we have a left-tailed, right-tailed, or two-tailed test. Okay, from there, we'll do some sort of statistical test and come up with a statistic for our sample, such as X bar. We're going to compare it to some things and make a decision. When we are doing this, too many things on my desk, we are given a level of significance, and that level of significance is usually alpha. And if you read in your book, excuse me, it will tell you what alpha means. Okay, so let's say that alpha is 0.10. If I have a left-tailed test or a right-tailed test, okay, left or right tail only is one-tailed. Two-tailed was our equal to, not equal to case. Okay, the author goes through and does a really great job of describing what that graph looks like and how to find the z-score from table E. But I'm going to tell you that we can use table F. We can use our cheater table, like I called it last chapter. And I have taken a picture. It's not horribly clear, but hopefully it will work for this video. On table F, if you have a one-tailed test, okay, a one-tailed test, you've got to make sure that you look across the one-tail line. If you find alpha equals 0.10 is what we said on a one-tailed test. Okay, we are not doing degrees of freedom. You ignore everything here and you drop down to the bottom to this infinity column that I just scribbled over the top of. Okay, because these are z-scores, we round them to 2 decimal places. And if you give me 3 decimal places, I will believe you're using a t and that you don't understand that we're supposed to be using z's. Okay, so while this is a t-score table, okay, the t-scores and z-scores approach each other, and if I round this correctly, this is what I would use for a one-tailed test, either left or right tail, for an alpha of 0.10. If I wanted a two-tailed test, if I had an equal to, not equal to case, my two tails with my alpha are here on the bottom row. Okay, maybe my alpha is still 0.10. Again, I'm not looking at anything on this table except the very bottom value there. And since it's a z-score, I'm going to round it to 1.65. Okay. These are values that we call critical values, I believe. I just covered up my book. These are the critical values. Okay. They are going to break our curve, I guess, into a region that will be a rejection region and a non-rejection region. Okay. A critical region and a not critical region, maybe they say. But if I am given my alpha, if I have a one-tailed test, I find alpha across the top here. If it's a two-tailed test, I find alpha across that bottom dark line there. Okay. We are not using the student's t-distribution yet. Okay, we are only using z-scores, but this saves us a lot of time playing with that table E and trying to go backwards to find those z-scores. It tells us what those z-scores are right down here at the bottom. Okay, 2.58, 2.33, 1.96, 1.65, and 1.28. Now, if for some reason I said alpha is 0.07, then we would have to use table E. But we're always going to stick with things like 90, 95, 99%. Okay, so our alphas will be one of these numbers on our rows. All right, so look at this along with whatever slides happen to be posted in our course, and there will be time to ask questions on Friday as we're putting all of these pieces together.